Okay. Thanks for the information. I'll let you know soon. Yeah, bye. Hi, I'm helping my friend shift his house today. He asked me to coordinate with the packers and movers. So I spoke to them on the phone and this is what they told me. If I hire one person, it will take 12 hours to pack the items in the house. 2 people will take 6 hours to do the same job, and 3 people will take 4 hours, and so on. Do you observe something here? Yes, when the number of people increases, the time taken to complete packing decreases. Similarly, when the number of people decreases, the time taken to complete packing increases. Here, when one quantity changes, the other quantity also changes inversely. So, we can say that these two quantities are in inverse variation. In general, if two quantities depend on each other in such a way that an increase in one causes a corresponding decrease in the other and vice versa, then such a variation is called an inverse variation. So, we can say that the number of people and the time taken for them to complete packing are in inverse variation. Now, if we check the values of the quantities in each case from this table, we can observe something important. Let me show you what it is. If we take the ratio of the number of people in the first and the second cases, we get 1:2, which can also be written as 1/2. Similarly, if we take the ratio of the time taken from both cases, we will have 12:6, which can also be written as 12/6. And on simplification, we get 2/1 or simply 2. What do you observe here? Yes, 1/2 is the reciprocal of 2 and vice versa. If two numbers are reciprocal of each other, like this, we can call them the multiplicative inverse of each other. That is, 1/2 is the multiplicative inverse of 2 and vice versa. Similarly, if we take the ratio of the number of people from the first and third case, we will get 1/3. And if we take the ratio of the time taken from the first and third cases, we will get 12/4. After simplification, 12/4 becomes 3/1 or 3. As you can see, 1/3 and 3 are also multiplicative inverse of each other. In fact, you can check the ratios from any two cases. You will find that the ratio of the number of people will always be the multiplicative inverse of the corresponding ratio of the time taken to complete all the packing. But what does this actually mean? This means that when the number of people increases to 2, the time taken to complete the packing reduces by a half, that is 1/2. Similarly, if we increase the number of people to 3, the time taken reduces to 1/3 and so on. Interesting, isn't it? There is another interesting thing that you can observe here. By considering the values of the number of people as x and the time taken to pack as y, if you take the product of the value of x and the corresponding value of y, in the first case, we have 1 multiplied by 12, which is equal to 12. Similarly, the product of x and y in the second case is 2 multiplied by 6, which is also equal to 12. What is the product of x and y from the third case? Yes, it is 12 again. You can check the product of x and y from the fourth case too. you will find that the product of x and y in each case is constant and equal to 12. This shows that as the number of people increases, the time taken to complete packing decreases and vice versa. And the product of their corresponding values remains constant. We can call such variation as inverse proportion. Two quantities, x and y, are said to be in inverse proportion if an increase in x causes a proportional decrease in y and vice versa in such a manner that the product of their corresponding values remains constant. In general, if x and y are in inverse proportion, they are written like this and read as x is inversely proportional to y. And when we replace the proportionality sign, the equation changes to x is equal to k by y, or xy is equal to k. Here, the constant k is a positive number and is called the constant of proportionality. Alright, now you have understood what inverse proportions are. So, let us see how we can mathematically apply them using the previous example. Tell me, what is the constant of proportionality in the example that we saw earlier? Yes, the product xy from all the cases was equal to 12. So, k is equal to 12. Okay, now that we know this, let's go deeper and pick two cases. Say case 1 and case 2. We know that the product of x and y from case 1 is 1 multiplied by 12 and xy from case 2 is equal to 2 multiplied by 6. Since we know that xy from the first and the second cases are equal to 12, we can say that 1 multiplied by 12 is equal to 2 multiplied by 6. 1 and 2 are values of x in the first and the second cases. So, we can consider them as x1 and x2 respectively. Similarly, 12 and 6 are the corresponding values of y in both the cases. So, we can consider them as y1 and y2 respectively. So, we have x1 multiplied by y1 equal to x2 multiplied by y2, or x1 y1 is equal to x2 y2. In general, if x and y are in inverse proportion, then x1 y1 is equal to x2 y2. Here, y1 and y2 are the values of y corresponding to the values x1 and x2 of x respectively. We can also write this as x1 by x2 equal to y2 by y1, or x1 is to x2 is equal to y2 is to y1, and read as x1 is to x2 as y2 is to y1. So, if two quantities x and y vary inversely as each other, then the ratio of any two values of x is equal to the inverse ratio of the corresponding values of y. Now, we can use the equation that we just derived to make calculations in situations where quantities are in inverse proportion. Let us check it out with an example. Here, 9, x, 81 and 243 are the values of a, and 27, 9, y and 1 are the values of b corresponding to the values of a. If a and b are in inverse proportion, then what are the values of x and y? Let us start with what we know. We know that a and b are in inverse proportion. This means that the product of the values of a and their corresponding values of b from all the cases are equal. That is, A1, B1 is equal to A2, B2 is equal to A3, B3 is equal to A4, B4 equal to K. Here, A1, A2, A3 and A4 are values of A, and B1, B2, B3, B4 are values of B corresponding to the values of A. From the table, if we substitute the values of A and B from all cases, we have 9 multiplied by 27 equal to x multiplied by 9 equal to 81 multiplied by y equal to 243 multiplied by 1. First, let us solve the equation 9 multiplied by 27 equal to x multiplied by 9 to find the value of x. On solving, we get x is equal to 9 multiplied by 27 whole divided by 9. Then on simplification, we get x is equal to 27. Great! We have found the value of x. In a similar way, we can solve these two equations and find the value of y like this. On solving, we get the value of y equal to 3. Alright, I have to go now to help my friend at his new house. But before I go, let us quickly recall everything that we have learned today. If two quantities depend on each other in such a way that an increase in one causes a corresponding decrease in the other and vice versa, then such a variation is called an inverse variation. Two quantities, x and y, are said to be in inverse proportion if an increase in x causes a proportional decrease in y and vice versa in such a manner that the product of their corresponding values remains constant. If x and y are in inverse proportion, it can be written as x is inversely proportional to y. If the product of the values of x and y is constant, then x and y are said to be in inverse proportion. If two quantities, x and y, vary inversely to each other, we can say that x1 y1 is equal to x2 y2, or x1 by x2 is equal to y2 by y1. This brings us to the end of the chapter, direct and inverse proportions. All that is left to do is to get better at applying all our learnings with a lot of practice. So, goodbye and keep practicing.